Did you?
Nah, I don't know what your fucking channel name is.
Alright.
What
Ooh.
is it? Oh, hold on. Nikas.
There is a way to do it from here, right? Oh, I think it's this. Oh.
Oh, it's already. What?
I don't know, it seemed that it worked. The audio was decent. Now, what should I do? What should we do?
Start a new political movement. Shit.
Well, I'm gonna list some of the things and you pick. We can do some SQLite stuff.
No.
No? You can do some bar stuff.
Like what?
Like what? We need to come up with the projects. I don't know. We can do some C stuff.
Hold on, I gotta clean up my shit real quick. Pro tip, move all your audio shit into one thing.
Wait, what does that mean?
No, I just had all my audio application thingies and separated. That's what I'm saying. Get the fuck out of here.
So maybe.
Buenos nachos.
So if I remember, I need to do something like this maybe. No. Maybe this. Okay, that is something. And then what? So no, I'm done. Okay. Oh, by the way,
What?
do you know how callback functions in C look like in assembly?
Oh, callback functions?
Yeah.
Well, I'm gonna be honest, bro. I've been dealing with callbacks a couple of times when I was making stuff. I don't know what the fuck it does, bro. I don't even know what it is.
Alright, let's try to figure that out. That if you want to. I'll look into this later. What do you think?
Yeah, sure. God damn. God damn. Oh, I'll be back. Python for Vim?
No. Should I?
No, honestly.
Why is it too painful?
It's not really that thing. It becomes a pain in the ass. Or maybe I'm not good at it.
Oh, by the way, what is the disassembler that I need?
PEDA. If you already got GDB, you need PEDA. Yeah. Oh, you already got NASM before it. That's kind of crazy. No, you start off GDB and you should have PEDA.
Oh, okay.
No?
I don't know. I haven't used this. You're gonna guide me here.
Okay, let me think. Should have done it. Oh, type in PEDA inside there. Oh, shit. Let me try.
I remember you were opening GDB and inside here you were typing something. Am I wrong or am I wrong?
No, you're wrong. You started automatically with PEDA. Is it PEDA or GDB? Okay.
So what is the general idea of a callback function? Oh, you can pass as an argument, right?
Yeah.
So I would say it's something like, the syntax should be something like this.
Oh. Okay.
So if I just want to just call it, how do I call this guy?
Wait, no, is that how you do that? What are you doing right now?
You think nah?
Also, I just realized that why is there a fucking I'm tripping. Nah, it's like the pointer and the when you run the function is not how you do it. It's already like pointerized. The idea is that the pointer belongs to the int. It's supposed to be int, pointer symbol, and then something. I'm pretty sure. I don't know.
You gotta be more precise with them lines now, because I have no idea what you just said.
Bro, it wasn't okay. But so basically, at line 11, you see how it says pointer sum 1 2. That doesn't mean nothing. What you gotta do is just type in sum. And also, at line 5, that pointer symbol is supposed to belong to int. Is it not? I don't know. Maybe in C doesn't matter where you put it, but I don't know.
Oh, this part
Yeah.
doesn't matter. I'm 95% sure. But this part, yeah, I am 3% sure that that's how it's supposed to be. Yeah, like, yeah, you're kind of right. This makes no sense. I don't like this either. But like, how am I supposed to pass it arguments though?
I mean, just run it and pass arguments. All it does is pass a reference to an int. That's all it returns. Like, okay, assembly-wise, think about it. A pointer to a function. Like, why? Okay, wait, that could exist, but that's not how you do a pointer to a function.
Give me your suggestion.
Oh, the whole idea is to make a pointer to a fucking function.
Why am I dash G? Dash O, right?
Dash O, yeah. No, wrong way around, wrong way around. First you need what it outputs the file name, and then the .c file at the end. That's usually, you just wrote it wrong. That's usually the standard with Bash, that the file you want as the input should be at the end. So, yeah, come on. I mean,
Oh, where am I? Oh, wait, it's not created.
You didn't save it, yeah. Oh, yeah, you didn't return a pointer.
Oh, yeah, I'm dumb. It needs to return. So yeah, whatever I wrote here makes no sense, right? Because what I wrote here is not a pointer to a function. It's just it returns a. That's what you. Yeah, that's what you were saying.
Yeah.
Yeah, you were right. Wait a second. I don't. No, not even that. Okay. Oh, I think I'm dumb. That's for sure, but. Yeah, I get the idea. The whole idea is that you got the flexibility with if the function has the same kind of what is it called?
What?
When the return type and the arguments are the same. Function template or something. So basically it's like this. I have something like this. Right here somehow I have to.
Okay, I figured out how to install Peda. I'm gonna drop it in your thing here.
Signature, yeah. So right here I need to be able to specify the signature somehow.
What the fuck is a signature? Also, if there's a pointer symbol, it's the other way around. It's the type and then the pointer symbol.
It's just a placeholder. So what should go there is like functions have signatures, right? Their signature is what they take as an argument, what they take as arguments, and what they return. So, for example, addition and subtraction have the same signature because they both return int and they both take int. Get the idea?
It's kind of like almost like an interface type beat.
Yeah. It's wait. Jesus Christ. Our guys here.
Oh.
Wait, how do I? Oh, I know how.
Yeah. I hear you through Discord, but probably in the live stream itself. Nah. Keep me on, keep me on. Yeah, I'm gonna keep them entertained. Yo, yo, yo. How's it? Yeah. How are we? Oh my God, these guys won't shut the fuck up. What are we doing? How we doing? I'm just gonna watch. I'm just gonna chilling right now. Got the brightest light on in my room, bro. Brightest in the room. I'm the brightest in the room. So uh, uh um yo, look, there's a fucking ant on my table. That's crazy, guys. It's crazy. Just threw him off. Actually, I'm still throwing him off. Now he's gone. Now he's cooked. He's not. Now he is. Rest in peace, random ant. Yo, hold up. Actually, let me use the internet. Let me. Uh, funny jokes. Alright. Alright, so I just found these jokes. It was the first result on Google. Let me read them. What did the horse say after it tripped? Help, I've fallen and I can't get up. Get up? I don't even get that joke, bro. Am I fucking dumb?
Guess who's back?
Oh shit, you're back?
We back.
That's crazy. I got so bored I started to read jokes.
Started counting backwards.
Yeah. I started counting to 1,000,000. Anyways, what's
Yeah, what's your idea? How do you what can be
How
a
do you blah,
possible
blah, blah?
syntax? How can you blood clot?
That's the thing, bro. I don't fucking know. Hold up, let me think though.
Something like this. This makes no
Bro,
sense.
that's fucking crazy.
Maybe whole thing goes inside like this, and then it's like
No.
this.
No.
Maybe you don't even tell it that it's a pointer, and then but it looks weird.
Are you telling me that bro created a function in a fucking function argument? That's 100% gonna throw up an error.
Yo,
Maybe.
you're telling me there is a problem, but you're not suggesting a solution there.
Listen, bro.
Let's try to run this. It is horrid.
That makes sense.
First of all, this whole shebang is crazy. Sum doesn't exist. Yo, you gotta work under a stressful situation. Life is not like
Still continues to clear.
life is not rainbows and
Sunshine.
sunshine.
Sunshine and rainbows.
It's nooks and crannies.
Nooks and crannies. You gotta get your hands dirty.
Arms heavy, knees weak.
You got the
Anyway.
weak hands. Soft hands. Yeah.
Oh, you know what you remind me of?
What?
Yeah, I know. My feed is crazy.
His feed is still crazy.
Whoa! Harder! No, there's nothing. There's no tricking here. My goodness, I mean, this is a ping
By
pong
the
ball.
way,
I'm
did
not
you
a
know?
magician. Come on!
What?
Like, wait a second, my headphone, right? It's crazy.
Oh, yeah,
I'm battling.
it's like a World War II operator, fucking comms operator. Bro.
I'm
In
lost.
In C, you can type like 3 equals 3 randomly in a function, and then it'll pass it as fine. What's your opinion on that?
In an argument,
Not just generally.
like here, 3 equals 3.
Yeah, 3 equals 3.
Okay,
Semicolon though. Oh.
yeah. So you're saying it can, on any line, it takes it and evaluates it, and this.
It goes into the void. It just disappears.
Oh, we can't check this right now,
Compiling, you don't say nothing anyways.
bro. Oh, that line. Will it get? Oh, you're right. Let's try it this way.
Bro,
I'm
slow.
bugging.
You're slow. But I can't tell.
So you're right.
Alright.
This did not throw any.
Yeah.
Did not throw.
Yeah.
Crow.
Isn't that crazy?
That's the craziest craziness I've ever crazied.
You know where I got that though? What? I got that from.
Yeah, this is fucking huge. Expert C Programming, Deep Secrets. You know that book? I got it from there.
Page.
Page 2.
You gotta cite it, otherwise it's like plagiate, plagiary. How do you say in English?
Plagiarism?
Plagiarism. Anyway, look, bro, search in that book like page by page. How do we do this?
How do we do
Callbacks.
What are you trying to? You're trying to pass a function to it? What's the big idea?
That's the whole idea of callbacks. At least that's what I assume.
Okay, so you can pass a function to a function?
Yeah, but like to pass it, it needs to be like you can't actually pass a function, right? It needs to be a like memory address to that function.
Yeah, a pointer.
Exactly. So, but you need like for that to happen, you need to be able to describe a type for a function. So, so type for a function is a signature. So I need to somehow type a signature here. And what is the syntax for it? What do you think? This is a puzzle. Like, I'm gonna start a fucking
Cold Wars.
timer. You're gonna give me an answer or I don't know.
Oh shit. Hold on. Let me bust open the book. Maybe it's in the table of contents. Maybe something. This fucking book does not. No table. Of
All
contents.
right, I'ma go and I'ma be back, and I better have an answer right here.
Bro, I could Google it.
How would you sleep tonight?
If I Google it.
Yeah, ask yourself that question.
That is. Hold on. Yo, this is some bullshit. I don't think this has anything about. Maybe programming book, right? No way, it doesn't have anything about pointers. Not pointers, but callbacks. So I'm sure somewhere just squeezed it in.
According to my calculations, it should probably involve this sign. Okay, let's start from there.
Well, does it now? What tells you that?
Because it's definitely a reference. No, I mean, yeah, to something. You're
If
passing.
that's true, why don't you just pass the reference of an actual function? Like, you could pass the reference. Like, yeah, just create a new function and pass the name of that function. Oh, okay.
You're confusing me. You're confusing me.
How am I supposed to create a new function, name it like ABC, and then as for the argument of that operator function, just pass like ABC and then a pointer symbol.
Wait, that will not work.
Why not?
How can that work? Like, that makes. Okay, bad idea, bad idea. Next one.
Abunai.
Abunai.
Is it weird though? Okay, I'm starting to think it's not in the book.
You saying that it's not deep secret?
I think it's more of an open secret and we're just fucking stupid.
Open secret. Open secret is crazy.
Oh, wait. Look. So there's you can pass a void. Hold up. Let me cook. Get token.
You better be quick.
Is this guy tripping balls? So I think the idea is, you can type like int in there if the return value of the function is int,
Right.
and then what you can pass in there is a fucking function. Like, wouldn't that work? Or another alternative way is to like, or the pointer to that int.
And how would you write it like this?
No, at the end. And like, call it like whatever, right? And then when you call that operate function, you just pass the function that you want to like run.
Alright, I have issues with this because
You can't run like, yeah, I don't, yeah, what is it?
on a basic level this seems right because you are passing just int because it's a memory address, right? And it's also
Yeah.
a pointer. But the
Yeah.
the problem here is that
What?
how does it understand, like the compiler on a
No.
level of C, compiler needs to stop you if you are passing the wrong signature. Like if I
You know what you do that? You create a new type. You create a new type and then like a certain that one function that you want to export that type.
type def something,
I don't know how types work. Let me look that thing.
that type def thing is just as I understand it, is just renaming and it's not actually definition of something.
Yeah, compiler at least deals with it, so it's useful.
Okay, now that I think of it, it needs to be something like this.
Bro, that'll never work. That's not how C works.
I'm telling the compiler that I'm expecting a reference to int, but it also needs to set some rules so that if the function that I'm
No,
passing
no.
doesn't have this
I
signature,
think-
then
I
this.
think- Bro, I think the big idea is that you create a new type, even if it's int, it just replaces int, right? And then you use that type to like that new type pointer as the argument to the function operate.
Alright, look it up.
No, oh, yeah, wait.
Yo, that book.
I'm 100% sure.
Yeah, I'm 80% sure that we can do that without declaring new type, but
New type just ensures that you don't fucking put actual random shit in there. Kinda. Callback. Actually, I've dealt with callbacks in C before. It is something like that. It has new other types that it uses. Okay, callback in C. What the fuck? No, actually, maybe you're right. So it's like void. Wait, actually, let me go. Okay, so I kind of get it. So here's the idea, right? The
Hey.
syntax of it is like void or whatever type, followed by brackets, and inside the brackets is add, and then the pointer, whatever name, right?
oh,
And then
not
under
at
that-
wait, like this, and then
no,
what?
pointer symbol, not that. That's the dereference, right? Yeah, not like that, not like that. No, delete those two, and delete the int. We're not putting the type in there. We're just naming it in there. That's the name of the argument. Yeah. So you can call it like X. No. You're not passing the arguments for the pointer function you're doing. You're passing. That's the name. So you can call it. Bro, just name it whatever. One thing. You're you're not. That's not the arguments yet. Yeah, like that. And then you.
Oh, it's like this.
Yes, that's it. But you missed the pointer symbol.
Like that.
There.
Yeah. Like, I should have been able to come up with this, but alright, whatever.
Okay, but you should know how to beat that as well. It's kind of. You have to pass the dereference function name. You get what I'm saying? For some reason. So, yeah, you wanna type in the 2 ints, and then the end is gonna be dereference or ampersand, add or sub, yeah. No. That means you're okay. That means you're pointing to a pointer now. Yeah.
Yeah, this makes sense.
Does it though? Because what is dereferencing a function? What does that even mean?
Well, we can disassemble it. Well, it doesn't work.
Why? Too few arguments. Where? Operator? Line 6.
I'm dumb.
Oh wait, Gina, yeah. Alright.
Yeah. Look at this.
This guy is crazy. He didn't combine again. Whoa, this is so cool.
This is craziness in front of your eyes, unfolding.
Alright, now decompile it. But before you do, check your Discord and run the thingy essentially. Did you watch that video of Soulja Boy music too loud? What? You're so mean, bro.
It's just jumping and shit.
You just jumping and shit, no pointed shit. That is crazy. Yeah, that's all. Now you run GDB.
Let me think about this.
Oh my god. Listen, bro, sometimes you ain't gonna think about stuff. Actually, you don't gotta think at all.
I agree, let's go.
No, GDB. Yeah, that happens, but it means nothing. Clear. Type in ls because you haven't loaded the file. And then wait, how the fuck?
Exec.
Shit. No. Wait.
Wait, exec means is
Oh,
it? Wait. Exec is a command in here.
There's quite a few commands. So basically,
But exec seems to be a command on its own, right? Yeah.
yeah. Well, okay. Run. Exec. Okay, can you exit real quick? I forgot how to load it through there. And then type in GDB and then the exec. Win. Start I. No.
Alright, I'm gonna be patient from now on. What we
Okay.
do.
Wait, can you type in info function?
Function as function or function name that I have in there.
Functions. Just functions. It'll list all the functions. Okay, I'm sorry to ask you this, but you gotta leave and join again. I made a mistake here. We shouldn't have started it because now it added all these functions. It loaded all them, dynamically linked it. Now it's gonna be hard to read. You get me?
You know that kind of shit is not free, right? The time costs money in here.
But I am made of money though.
So what do you want me to do?
GDB exit. Exec. Yeah, go. This has. No, not this has. Sorry. Fuck. Info functions, yeah. Right.
Wait, what was
Now
different
it's-
this time? Oh, I didn't type start I, right?
Yeah. When you type start out, it loads all the shit. So okay, now we're gonna. What function should we disassemble first? Okay, let's disassemble main. So, disas main.
Now let's think about this. If we disassemble main, what we'll get? Oh, this is annoying now, but it is what it is.
It's just gonna be comparison, and that's all.
Yeah. Yeah, we care about this guy here, right? Mostly.
Yeah. I should have a pointer to that function exactly.
And we also care about this guy because what this guy is taking is also, yeah. So basically operate and main.
Well, okay, you won't be able to tell the arguments that are required for that function, unfortunately, because assembly is in such a way that it doesn't tell you what the function arguments should be. You get me? You
But
can only get that.
we can see how it builds the stack though, right?
You can see which registers it uses, but you can't see, like, you get me, like what types are needed or some shit. But like, sure, if you're running it, you can see the stack and see what's going on.
Yeah, like as I understand it, it's gonna put 3 things inside the stack in the beginning of this function. No?
It's gonna put 3 values in 3 separate registers.
You think?
You compiled x64. That is true in x32. You know the 32-byte programs. That's how 32-byte programs do it. The 64-byte programs put in the register.
All right, I will trust you. But okay.
Common knowledge.
Common knowledge, okay. Common sense.
Yeah.
But I think I'm gonna rephrase what I said because I was wrong.
What?
The operate function will not do this. The operate function itself is basically first you need to push this from main, right? So inside main we will see either a building stack or 3 things gonna be put inside some registers. Is that correct?
Yeah, 3 things will be put in. Yeah. Look, you can even see like
These guys?
Yeah.
Or maybe
Yeah,
these
look at
guys.
that. No. Bruh.
Maybe. Oh. Okay. I'm gonna.
Wait, hold up. Okay, wait. So it calls the function operate at line 28. You see that? And the like 4 lines before it, it's loading the arguments for that function. I don't know why it's doing the rax rip that.
It's basically this guy, no?
No, I think that guy just straight up got taken out by the compiler.
Yeah. Makes
He got
sense.
disappeared.
I know. This is less than equal, doesn't it? Isn't it?
Nah, that's leave. I don't, bro. I'm gonna be honest, I don't know what the fuck leave does, but I know it's close to at least a mov. So it's RAX. So look, it's moving RIP plus that thingy, which is basically the add function. That's like constant. So it loads the function, but like, oh, you see that? It loads the function. It's like, wait, let me take a look. I'm trying to figure out if it's a pointer or not, but I can't really tell. It probably is a pointer. Yeah, it is a pointer. It is a pointer. So it loads a pointer into RAX. Then RAX goes into RBX. You see that? Yeah. And then, yeah. Then it just loads 2 in the ESI and then 3 into EDI. See
Yeah,
that?
this is easy part.
Constant values. Yeah. And then it calls the function, and then boom. Okay, so after it's done with that, it's gonna dword pointer RBP. Okay, that's some like print stuff. Oh wait, actually, let me think.
You think this is
RBI.
this is basically a setup for this guy?
That whole bit is like the int s equals part and the printf part. That part is like setting the parameter of print, and the EAX dword pointer and the ESI EAX is probably the int s equals. You get me?
So you think this guy is the callback ID or something?
No, that guy's straight up print.
Yeah, print, but
That's just
not callback, but the system call.
system call. No, that's not a system call. That's just a fucking print. That's just a dynamic logic.
You're right. You're right. We are right. The system call is basically inside of this guy. I'm done.
Yeah. System call would have the instruction syscall straight up. Right. So I'm trying to figure out. Basically, it's printing at the end.
So you say this whole thing is the print, and
Yeah.
this is basically the exit, return 0.
Yeah, that's the return 0. The leave is to clear the stack of like what it built up, and then correct.
So so this is the important part then. These two.
Yeah, let me Google what the Lee instruction is. Load effective addresses. Oh, I know. Okay, so it's basically like mov. Effective addresses is like a certain section of memory that's dedicated to like code or functions. And so it moves that basically pointer to the function to RAX. So RAX becomes contains a pointer inside of it. I'm pretty sure that's what happens.
I'm gonna tell you what I have qualms with here. I would expect there to be instruction pointer, aka IP, right? But I don't see any. Oh, this guy, maybe, right?
Why do you need instruction pointer here?
When you're calling something, you need an instruction pointer, no? What are you calling?
If you're hacking it, you manually need to overwrite the instruction pointer. But it's not hacking it here. All it's doing is just when you call the call instruction, basically it does overwrite the instruction pointer. You get me?
Let me think. Okay, this is my understanding of how it goes. When you call, it basically looks at whatever it is at that moment inside the instruction pointer. No?
No. So first, okay, the whole idea of the call is that once the function that you called hits ret, it goes back to where it stopped. So first of all, what it does is that it adds to the stack where it last stopped. So it's gonna be that +28 line. And then what it does next is that it basically does mov RIP, which is the instruction pointer, that function, okay, 0x1139. So it puts that 1139 in the RIP, okay, the instruction pointer, and then it starts doing instructions from there. And then once it hits ret, you'll clear the stack and read what's at the top of the stack, which is this address in memory where it last did the call.
Yeah, you're gonna basically jump here, right?
Yeah.
Or basically jump here and continue from here.
Yeah.
But like, where did this number come from?
That's just the raw memory address of that function.
So you think OS managed it? Like, this is the free part that you can do it, or
What do you mean?
okay, this is memory address, right?
Yeah.
Is this the offset or basically hard-coded memory address?
That's offset relative. Yeah, that's offsets.
Yeah, that gotta be an offset. So what I said previously makes zero sense. Yeah,
So
that's
if you restart like the program, that should be the same.
yeah, I got it.
Sometimes it isn't though.
But I still don't get this part. Well, did you?
Okay, so Lee, I searched it up, very brief, and it said it was an effective address loader. So effective addresses are addresses that's like a limited amount of addresses basically. It doesn't cover the whole memory space that it could. So past some point you can't have more addresses. You trying to get what I'm saying? Okay, well let me re-explain.
Okay, yeah, I think okay. You're explaining the functionality, but let explain the usage utility.
Probably. Wait, let me Google.
Why was it necessary to do it here?
It might just be optimization, but I'm searching it up. Compute the effective addresses of second operand. The second operand is the thing that's in square brackets.
Yeah.
And store it in the first operand, destination operand. The source operand is a memory address offset part specified with the processes returning processors addressing modes. I don't know what that means. The destination operand is general purpose user register. Okay. The address size and operand size attribute affect the action performed by this instruction. Okay, that makes sense. As the following table, as it's shown in the following table, the operand size attribute of the instruction is determined by the chosen register. Okay. The address size attribute is determined by the attribute of the code segment. Jesus Christ. Okay. So if it's 16-bit, that means 16-bit effective address is calculated to store 16-bit destination order. Or register. Okay. Fuck it. I'm having a hard time reading this, but the whole idea is to somehow use offsets basically. But let me look into it further. Hold up.
So how does it go here? It's right to left side, right? It loads right side into the left side, right?
Yeah, it should be. So, okay, wait, let me.
Yeah, it makes sense because.
Yeah.
Yeah.
RSI.
Yo, what if I have like 100 parameters to one function? It's still not gonna build a stack. What would happen there?
What happened there?
Yeah.
Oh, like if you had a bunch of parameters.
Yeah.
What I'm thinking is that probably just loads into the stack and then later puts in the fucking registers. But yeah, probably. Maybe we should check that out later. Alright, so
I still don't quite understand what manages and how the RIP is managed, but I will look into it. And
RIP is just correct. Like, okay, if you don't override it, it just manually goes up, up, and up.
yeah,
You get me?
yeah. So that means the what starting point is set right when the program starts running. Because up and up means like starting from where though? Or am I thinking about this incorrectly?
Hold up, I need something.
Alright.
Oh, I get the idea.
Right, listening.
So basically the idea is that the Lee instruction is for calculating memory addresses somehow. And so you see that RIP plus that memory thingy?
Mm-hmm.
That plus and the big F's is
Mm-hmm.
basically just an offset. Not like an offset in terms of like a thingy, so it gets the destination. So that destination is that function up there, the add function. So basically, you use the RIP register calculating that, because the RIP will always be constant in that spot, right? That makes sense.
Okay. Does that mean basically in the beginning the starting point is set for RIP, whatever it is, right? Then
No,
compiler
yeah.
compiler kind of knows how far the add function is. And then what it does is it adds RIP, the offset, to get to add, and then it calculates the actual address for that. Is that the idea?
Yeah, I'm kind of confused as well, but because oh, actually maybe not. Actually, I kind of am, right? Because you're adding that, but like he's at 118B, right? At that RIP is 118B. Because look on the left side, you see those streak of fucking memory addresses? Yeah, that's the RIP at that moment when it's on that line. So that's way past add, because it's 115D. I'm sure it does something like it loops back around. Probably that's what happens, or something like that.
That's what Lee does. But like you're saying, this is basically RIP at this moment. Is that correct?
When it's on that line, yeah.
Let me have let me conceptualize this. So there is a loop, right? And that loop means you need to have a loop. Yeah, CPU loop basically. And the loop is built in such a way that it always gets to the RIP register. And yeah, RIP register is basically the most important register in that sense that it cannot be. You can't really escape using it. It's very integral to the whole, which makes sense. So
I tried reading all of Berserk in 24 hours.
so what happens then is
What happens then is you go crazy and die. Yeah, well.
not only that, but it's actually on board inside CPU is probably built in such a way, like how to update the RIP, right?
The chips on the CPU itself, probably.
Yeah, like how to feed RIP like on each cycle.
Mm-hmm.
So you basically need to give it a starting point, and what it does is like it rolls through the next and the next and the next.
Mm.
Oh, yeah, I'm missing something though. Because
He's missing these.
uh,
These. Ah, got it.
what is written inside RIP?
Good mythical morning. Wait, what? What are you saying? What are you dropping? What are you dipping? What are you dibbly dabbling? What are you hubbly hebbling?
Yo, inside RIP, like
There's a point. Yeah, what?
is there a
Got memory address.
Yeah, that's what I wanted to know. Like, is it pointing a memory address, or the one you write something inside RIP that is already an opcode?
Nah, okay. You don't load raw opcode in the fucking instruction itself, no. If you start running the program, it'll show you what's in the RIP register, it's just the memory address that points to the opcode.
Yeah, that's how it should work. Yeah, I guess, because yeah, you need that flexibility.
And with that flexibility, so many exploits exist.
So you get the memory address inside the RIP, and inside the memory address, when you get there's an opcode. And the next thing that needs to be done is that grab that opcode and run on the CPU.
Yeah.
But if that opcode is MOV, for example, right?
Yeah.
Which in this case is like after Lee EA finishes, the whole cycle probably is to go inside RIP, check whatever is the next memory address, go there and load that thingy, whatever there is on that memory address, the opcode onto the CPU, and now you get this. But what happens with these guys?
Well, what do you mean? Those two are basically almost virtually the same thing. Those two instructions. It gets what it. Okay. When it calculates when the Lee instruction calculates what it needs to be, it just moves it into RAX. What are you trying to say?
What I'm trying to say is that how the opcodes work. Like this.
Oh shit, bro. That's like you need like a fucking pro.
Not how they work on a D+ level. What I mean is how they are encoded, like on a simple level. Like
dude, like the hex, like it's actual, like just fucking actual codes. So
yeah.
It's like 0x01 x0.
Wait for a second. I'm gonna explain you what I'm asking.
What?
So this on a 64-bit system, this guy has 64-bit, right? Takes the whole thing. Yeah. Okay. So what happened from the previous cycle? Let's say that's the case. Let's assume that. So what happened from the previous line is that when it finished, it goes to the register, RIP register. Looks whatever it is, goes to the path, whatever that is, gets the whatever there is, loads it on the CPU, right? And that's for full 64-bit. But then, okay, move is kind of run on that guy, but how are these two guys encoded?
Let me think. That RDX and RAX themselves should be memory passable. Oh, you mean how do you move from register to register?
Yeah, like move kind of activates some kind of logic, but you need to specify like how do the arguments work in assembly level, get it? Like on hardware level.
I mean, so looking at the memory addresses to the left, you can kind of tell what's going on. It's actually in the fucking memory itself, because it's not perfectly counting upwards. Because look, it's 119, or yeah, that move instruction is 1192, but then the line after is 1195. That's like three. Wait, that's 3 bytes. Wait, no, that's 3 thingies. That's 3 values.
Yeah, I kind of don't get like why this is inconsistent from one like +3 then +4 and then +7
That's
3
because
again.
that's because the amount of bits each instruction takes differs. I guess. I don't know. Wait, it shouldn't be though, right? Wait, actually no, maybe it is.
No, I don't think so because I think each instruction kind of takes 64 bits and I might be wrong there.
Yeah, maybe that's not the case.
Okay.
That's a lot. That's a lot to look into. Anyways, what were we trying to discover?
Well, I'm thinking about like why is this necessary to be able to that you have to be able to change RIP at all? Because it seems that the hardware itself like is using RIP as you like as it's already needed. Get me?
Why should you be able to change RIP?
Yeah.
Yeah, why not? I don't know. It is kind of like that. I don't know.
So we don't understand something about that. And now it's bugging me like
Bro, RIP is just a register like any other register. You can edit it like any other register.
but but
Just go edit it.
but that's basically what I'm ranting about right now. That it's not.
It
It's
is. Why not?
because it's the some kind of logic is hard coded around RIP more than about others because okay, you finish this guy, right? Then the how do you jump on this instruction is completely managed by the CPU itself and it's attached to the RIP.
Yeah.
Yeah, like for example, rocks, like CPU doesn't care about rocks probably. Like whatever you write there, whatever.
No, it doesn't. But like, here's the thingy though. Oh wait. But there are some instructions that use like RAX and shit like that. Like, I'm pretty sure there's a multiply function that uses RAX and RAX only, or something like that. Stuff like that exists. The reason it's a register like any other register is so you can load it into other registers. So you can move like RDX, RIP.
And why would you need that to do that though?
Maybe like debugging purposes. Maybe like I don't know.
That seems to be the biggest biggest tickets right here. That's like at this
What?
point it seems to be the biggest reason why it's important to be able to manipulate the RIP. Yeah.
Yeah, probably.
Because if you're not able to like look at RIP or like or change the RIP because like isn't like debugging jumps complete like all about probably about changing RIP value.
Yeah.
But at any rate, like now I want to know like that's the first thing that I have to figure out. If this guy takes 64 bytes and it's being loaded on a CPU, how are these arguments loaded after it? Because these guys are not instructions. Get me what I'm saying? These guys are just continuations of MOV. But when does this continuation happen though?
Bro, an assembly almost okay. Either an operator takes two arguments or it doesn't. So, like for example, leave and ret have no arguments at all. Oh wait, that's not true though. It could have only one argument because look, call has one argument.
Push has one argument.
Push has a argument. So I'm pretty sure if you try to pass like two arguments to push, even if it were to be possible, like you fucking hop in there and you start changing the hexes, it would give you error for it. Or like if you do like push, but then it gets the opcode for mov, it's probably gonna crash. Nah, pushing crash on that. But you get what I'm saying. You should create a.
Alright, where am I? I'm back. Back to reality. Yeah, I guess if I ask like one simple prompt to ChatGPT, yeah, it will give me an answer. But I'm too lazy right now. Alright, what should we do now? Like, do we understand what's going on? Still?
That leave thing is still a bit confusing, but I kind of understand what it's about. I don't know why it's doing that, not like statically, like actually just pointing to the function, like call is. You know how look how call is doing the thing. At line 56.
Wait, what? Yeah.
See, it's straight up pointing at a static. So probably because the compiler changed it up a little bit, and because you typed ampersand, ampersand and, or ampersand add, it did that, turned into that. You get me?
Well, in these kind of situations, I think the answer is usually optimization. Is balls.
Yeah, optimization. I wonder if you type in just add, what will happen?
Well, I don't think it will compile.
Why not?
Because the type, it's
type.
type mismatch.
Where is add itself? I guess it contains the actual like function somehow on an abstract level.
Where's add itself?
Yeah.
Well, this guy knows where the add is and then tries to smartly calculate that value and put inside RDX.
What if you disassemble it operate? Did I say disassemble it?
Well, you can check it.
Okay. So ignore the push RBP, move RBP, RSP, and sub. Oh, the sub. Yeah, ignore the sub as well. That's doing stuff to the stack. So when the function is done for, what it built up goes away. So okay, let's look at this. What the fuck is that, bro? RBP? Wait, isn't that base pointer? That's the stack. Okay.
These are the
RDX.
so.
Wait, I'm pretty sure it fucking loads into the stack. It loads those values you put arguments in the stack.
What does this mean though?
It specifies the length of what it's loading.
Oh.
Or something like that, basically.
What is
PTR
RBP?
obviously means it's pointer. RBP is base pointer. So it moves EDI in the base pointer, okay, in the stack. And then it moves ESI. What is EDI? What did you load into EDI?
So it did build the stack, but like it's without push?
Okay, yeah, it's possible without push. It literally moves it into the memory address of the stack manually.
But what does minus mean? Like before RBP, Okay.
That means like that's like an actual minus. So I guess the address of RBP minus 4. So 4 steps, 4 bytes back.
Wait, like if stack is built from bottom to top, then if RBP is pointing at the most top one, right?
Okay. Wait.
How are you
That's not
going
true.
back and
RBP looks at the most bottomest, but look at the line 1 plus 1. It says like move RBP RSP. So it moves the pointer of the top of the stack to RBP. Just so you know. And then for some reason it subtracts 10 to RSP. So it moves RSP is pointer down. You get that? You understand?
wait, what is the base pointer for?
Base pointer is like at the bottom of the stack, way at the bottom.
And the SP is the top, right?
RSP is the top, and then look, it basically moves they're both pointers, and so they both contain just memory addresses.
Yep.
So it moves the memory address of RSP, aka the top of the stack, into RBP, the bottom of the stack. But it doesn't move it. It doesn't move it into where it's pointing. It moves in the register. Get me? You get what I'm saying?
Yeah, RSP is still RSP, you're just like overwrote the RBP, yeah.
So RBP is not the same as RSP. They're both pointing at the same thing.
Yeah, at the top.
Yeah. And then what happens is RSP basically minus 10 there. So basically it moves down, moves down, so it doesn't move up.
Yeah.
10. So RBP at this point is higher than RSP. Oh, I get it, bro, you get it? Bro,
Wait, don't say anything, I'm gonna think about it. So you said, yeah, RBP is lower than RSP? No, RSP is lower than RBP. Oh, that's why you remember this. You basically want to, yeah. You want to remember what RSP is, and then RBP is at the top right now. You wrote these values.
Can he figure it out?
Bro, there now between RSP and RBP there are these values.
Yeah, that's it. That's how it did it. That's how it builds a stack. That's how it creates a little bubble in the stack. So now you know the values of this function. Yeah.
But
you can clean them up after you're done. That's the big idea. That's the big idea, pal.
wait, what happens here? RBP OXA. Okay. Inside EDX, EAX, RCX.
Wait, I'm gonna be honest, I kinda don't understand because of that push RBP at the top, but okay, let's ignore that, that's some stuff. So, okay, so basically, look at what it does, it's pretty simple. It moves the EDI, ESI, and RDX into the fucking stack, right?
Again, yeah, it is accessing these numbers and again put these in these registers, right?
Yeah, pretty much that's what's going on here.
But then
So, what is EDX? Okay.
oh, see, this RCX is basically this guy, this operate guy, and then calls it.
RDX. So wait. RDX is RAX. So RDX is the pointer to the function, and it calls it. Right? Yeah, and it calls it. Yeah.
But before that, he's putting these values again into this thingy.
That's the argument. Yeah.
Yeah, again, like it does whatever he did here, he's doing here to call this guy. which is like, of course, you're gonna do that. It's the same thing over and over and over.
Yeah, so that makes sense.
How does the cleaning happen though? Cleaning up.
That leave.
What does it
Still
do?
don't know how it works, but
Yeah.
kind of don't know how it works exactly, but somehow uses it. That's why there's a whole push RBP, move RBP, those things. When you run a leave, it somehow takes it out.
But isn't it weird that RSP at this moment is looking at something that is not RSP for real?
Yeah.
RBP is holding the actual RSP.
Oh shit. You know who came?
Who?
Batman.
Yeah. You heard what I told them?
Yeah. So okay, so run it. You wanna run it?
Yeah. Why not?
Okay, this has functions. Oh wait, I got that wrong. It's info functions. And then you wanna double click on main, the address, memory address. Oh, actually, never mind. You can do break main. Okay, and then R, just R, then enter. Okay, so now we're in the start of main. So you see that code? That's the instruction. Stack this stack. Registers is registers. Everything should be pretty understandable right now for it. You see how Linux is like passing all the fucking like Linux stuff, like the shell it's using, where its location is as the executable. You see that? Isn't that cool?
You mean these guys?
Yeah.
These guys.
Look at RIP. See, it's a pointer to the thingy. You're just holding a memory address.
How from this guy he's able to construct this thing?
I mean, look, that exactly matches up what's in the code section right now.
I mean, yeah, but like, Yaman, but wait, I need to figure the
Look on the
question.
leftmost side.
What did you say?
Look at the more left, the memory address side of the code. Yeah, you see, that's the same as RIP.
I know, but like, okay, let's say I know. This is inside. No, this is not inside RAM. This is not RAM location. This is
RAM location.
but it's relative
Oh, wait.
though.
It's virtual address, probably. I'm pretty sure that's what it's called.
I think this is probably an offset inside the like these processes relay, right?
Yeah. Shit, you hear them?
Not really.
Good.
So anyway, let's say I have that thingy, right? How do I construct this guy from this one, this data?
Well, it's just a memory address. So basically, this is how it works if you deconstruct it. Basically, there's the opcode for sub, right?
Yep.
And at the beginning of that opcode, that's literally the address of the opcode. That what you just highlighted. That's where the opcode starts.
Yep.
Yeah, I mean, and then you just read the opcode and you get it out, and then you read what's next, which is RSP, and then you read what's next, which is 0x10.
Yeah, but like I'm asking, the program is running and debugger is running parallel to it, right?
Oh, you mean how the debugger?
Oh, I think I know. I think debugger basically wraps around the whole program in
Yeah,
a sense
yeah.
that, yeah, if that makes sense what I'm saying.
It probably does that because, right, you can access this process you're running right now, but it can't like access any other process if you try to get the memory address of it.
Yeah.
So it probably like injected something, like got in it or something, or wrapped around it probably. Look, next instruction, N.
So the breakpoint logic about inside the debugger is probably like, okay, I know I'm gonna call this guy. What debugger does is actually looks into whatever is written, gets all the data. So yeah, debugger kind of knows everything that is necessary to know, I guess. But I don't really understand much. All right. Anyway,
Next.
and
Yeah. Oh, this is that thingy. This is that thingy. I wonder where. Okay. So look up in the registers. Nothing has changed yet. Okay. So, next. Okay, wait, stop. So on the LAX. Yeah. You see in the RX push RBP. That means it loaded the function. I'm pretty sure that's the first thing of that function. First instruction. Yeah, that is. Because that's how every function starts, remember? Push RBP. Even the function we run started with push RBP.
oh, so this has nothing to do with the. No, it should have about add, right?
That is the function add. That's the first instruction of function add.
Oh, I get you.
If you dslash and then you type in that memory address, it'll give you the function add.
Yeah. I do remember that. It is that, but. Oh, I think I understand. RBP basically, I think it stores the where I am right now.
Oh my god.
And if that's true, oh yeah, you're right. This is how it works basically. RBP does a save where I am right now. When I jump to a new function, I understand how many variables as a parameters I need that, right? So I fall back the stack from RBP backwards and I fill up that place, right?
Mm.
Okay, so I did that.
Alright. This is better, probably.
It also pushes RBP inside the stack itself.
Wait. No, it doesn't. Does it?
Push RBP, I mean. Yeah, wait a second, I have to save RBP in the stack itself. Why though?
Oh, if I remember correctly, the red instruction pops what's at the top of the stack into the RIP. Maybe that has something to do with it. Oh no. So here's what's going on. The reason it's doing that is that, for example, if you call another function inside of that, it'll remember the stack editings that it did. Remember? Get me? Me?
Wait. Will not all of this make sense if, like, if RBP is the previous function where you're jumping from?
No.
Because it kind of
No.
tells you where to jump back.
Bro, once the leave instruction runs,
Yeah.
it clears up what the function had, and when it hits ret, okay, what call does is that pushes where it's at currently, the RIP, and then afterwards it overrides the RIP and goes to the function it needs to run. When that function is finished and it hits leave, that means it clears up the stack of what it added to the stack, right? That function, and then at the top of the stack is the memory address that call left, okay, when it pushed the RIP. And so that means when the call instruction was ran. So basically it continues where it left off, because ret pops it and puts it into the RIP register. You get it?
Oh yeah. Well, I mean, the pop parts. That's what made me kind of. I don't know.
The pop just reads the top of the stack and moves it to the any register you want. But ret specifically moves it in the RIP register.
So what are you saying? What is stored inside our RBP?
Oh, the idea I was saying was that, like, okay, for example, we have a function, right?
No, just tell me like what is stored inside RBP and how it changes.
Oh, RBP is base pointer.
Yeah, but what does that mean?
Stack, like the base stack pointer.
All right. Let's move forward.
Actually, to be honest, that's what I'm thinking what it is. That's what people are saying it is. And so look,
And we get this.
alright, it's gonna call, and then look in the stack, right? So, wait, let me cook. Wait, don't do it. Okay, go. Next.
Yo, where is the stack?
Uh,
This guy?
yeah, that's the stack.
Wait. Okay, this is where it started. This is where we are.
No. 000 is atop the stack, I'm pretty sure. Like, hit next, and you'll see.
What do you call top?
Top of the stack is top of the stack. It's RSP. Things get added on top of the stack.
Yeah, things.
0 was the newest thing that got added on the stack.
Yo, how can that make any? Oh, actually, does that make sense?
When you push something, that's what it does. Look. When you push something, what it does is that RSP is a pointer, right?
Wait, wasn't this the last thing that was pushed though?
No, nothing like that was pushed.
How did
So
this?
listen.
Wait. How did this end up in the stack then?
That's before something else did that. It's like before we stopped that main, it was running a separate function. It was like an underscore init function.
Okay, let's see. Okay, you're saying that. Well, basically, what you're saying is there is nothing gonna appear that is higher than 0056.
What? No. Like, okay. Bro, think about it logically, alright? This is what the push instruction does. first it gets the RSP, right? That's the top of the stack, and then it adds something new to it. And then after that, what it does is that like it subtracts it.
It doesn't
It
mean.
what?
Okay. Okay, RSP is the top of the stack, right?
Yes.
Okay, if RSP is top of the stack, how push happens is that it gets the top of the stack, it looks the size of the thing that needs to be pushed, it takes that amount of space, it writes something inside that space and changes the RSP.
That's already wrong.
Why? Explain yourself.
First of all, we don't change the RSP. This is what happens. Okay, through the RSP register, that's a pointer. It's pointing to the top of the stack, and then it's all like it can't detect what size it is. There's no detection. You have to raw like if you want to write a different size, you have to say that you're writing a different size, and then once all that happens is that mov RSP and then the value you want, whatever you want to push. But then what push also does, it does that basically, and then it does that, and then it also pushes the RSP upwards. So basically RSP how do you say, add RSP 4 or in 64-bit that would be like 8 or something. You get it? Like you move something into it and you have to move the stack up afterwards.
Exactly. That's why.
No, actually
That's what I said though.
The stack pointer is already pointing at something empty, I think. Maybe. I don't know.
You have to add RSP8 makes sense because how add works is that you're changing whatever written inside of that register, right?
RSP.
Yeah, so I think that is a necessary step, but I think that I did say the same thing though.
Pretty much.
I'm too tired to think about this right now though.
Oh man, but like this is like, okay, go next.
Should I pull up Paint?
Not yet. Wait, check this out though. Look at the top of the stack.
Okay.
Wait. What the fuck?
Wait. Okay, at least this needs to have an effect on the stack as you were saying, right? Because
no, because look, it finished already for some reason.
oh yeah.
We're still in main. For some reason it didn't disassemble what was going on.
Exactly. But this
we need to break operate.
Yeah. No?
What?
Okay, I'm done.
RCX is EAX, by the way.
And nothing gonna happen at this point.
It's gonna print that.
Alright.
And then return and basically end. Oh, yeah.
Now
Oh, now this is outside of main.
now we are inside libc.
This is basically what was running before your program.
Yeah. Well, basically called my program probably, right?
Yeah, it called exit straight up. Okay. We need to break, what was that function? Operate? Yeah. Okay. Run. C to continue all the way up to there. Wait, okay. Yeah, now we're operate. Okay. There should be mains. Yeah, you see that? There's main there.
So once it's done with a function, that's gonna be at the top of the stack, that main, and then once it hits ret, it'll pop it and go to main. It'll set the RIP register or the instruction pointer. Get it?
I kinda still don't get it why it's going from high to low, the stack.
Wait, is it though? Is it counting down? Oh wait, it is kind of counting down. Yeah, I don't know. That is weird. That is weird.
And what do these represent as well?
That's a pointer to a pointer to a pointer to a pointer pointing at 0.
Hell
I
yeah.
don't know. I don't know. But actually, if you analyze it, actually not.
Mine being bang. Okay.
Your brain is fried.
I can't concentrate right now. I need to look around. Actually, enough screen today.
You can never have enough screen. So that's the golden rule.
Like if I just read how the stock works, like straight up, it's gonna take 3 minutes to understand this. We are trying to figure it out how it works. Should we try? Alright.
Stack. I'm telling you, stack is used by the call instruction, and the ret instruction goes to the value. Yeah, that makes sense.
So it's not hard. It's called a stack, but you're not hard locked to use it as a stack because you are able to change the stack pointer and.
Yeah, you can. Yeah. Just like you can change the RIP, you can change the stack pointer.
What does this mean? Because of its frequency of use.
A bunch of people use the stack, so yeah, that's why people need it.
Well, if people use it, then why other CPUs should not do it? I don't like this reasoning basically. The argument seems off. Like, what does it mean to be without stack? Because
They have no stack built and stuff.
if you have RAM and register,
You can create a stack, sure, but he's straight up. What he's trying to say is that x86 already has like built-in instructions and opcodes for dealing with a stack.
get it? You understand?
I think
Picking up on
he implies something stronger than that because, well, it doesn't really matter to be honest.
Whatever, just bad writing. Wait, what else you gotta say?
Oh yeah, he basically said, yeah, okay.
See, bro?
I always know, bro. I always do.
Okay, now this guy actually gave it gave the reason. The reason is pushing up stuff from the stack happens so often that it was a good idea to use a short opcode for them, less code space. Okay, that is an answer. It's not like, oh, people just use it so frequently. Oh, they have stacks.
This
It's a
isn't
so
2009.
most of the oh, this guy. This is a whole debate going down in 2009. People existed back then.
People lived. People had computers back then. Internet. Millennials, boomers.
So these kind of things do seem like most of the times to be about optimization, and probably MIPS and ARM don't care about that optimization.
Wait, no, that's not true. They're actually one of the most optimized shits ever.
Yeah, but optimization is can be like different. Can be different for space or for processing. This seems to only optimize space, as it seems.
Yeah. Wait, bro, you made me forget something, bro.
Oh, the ARM basically tries to optimize the number of instructions. Of course, it will try to avoid something that you can implement with other instructions.
Yeah.
But at any rate, instead of analyzing those, it's probably better to think about actually how it works. So, special. You know, so it makes SP on a x86 special as well, but on our CPU it's still it would be a general one.
Yeah. Probably on ARM, every single one is a general.
Except the instruction pointer again.
Yeah. Well. Yerp. 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 Chief Aramaki of Section 9, Public Security.
Why are you here? Because my boss. Oh no.
That's basically Ghost in the Shell for me. Bro, basically you get it, right? You get it, right?
How it clears up, I want to understand that one.
Alright, here's my little take on that situation.
Okay. Google what the leave instruction does. That plays the role. I'm pretty sure what it does is that it like eliminates everything that's between the stack pointer and the base pointer. You get me? We'll search it up.
We're getting there.
X76. No one came out. No one dropped. Wait, is this the same? No.
Well,
Yeah, I read about the enter instruction. People don't use it anymore. It's not optimized. Even though it still exists, you could still use it.
should be replaced with. Okay, let's see.
Push
Base
TP.
pointer.
Push the base pointer to the whatever the stack is. Yeah. Core.
Yeah, it is right. It refers to high addresses, so it kind of moves from right to left.
What? Does it move from up to down or no? Wait. SP should move upwards, right? Oh wait. I don't know. What do you mean? I'm confused here, bro. You're confusing me. Chief. That's great.
Alright, I understand. So it moves left to right, and that's why it kind of looked weird that it was minus.
What do you mean by left and right though?
So, I mean from right to left. By left and right, I mean like from 0 to whatever, right? The memory goes by 0, 1, 2, 3, 4, right?
Okay.
So from right to left
From
means
up
it
to
goes,
down?
yeah, from higher values to lower values.
Yeah, that makes sense.
So when you're RBP and RBP is looking at the bottom, you and you are building a stack, you push this guy, and then you minus from there and put stuff along the way, right?
Yeah. Probably, yeah. The whole process is just optimization. And clean. Clean.
BP is
Bro,
pushed onto the stack and
I
set the.
pulled up the live stream. I sound like I'm in the fucking in the distance in the mountains.
You're speaking from the moon.
Yeah.
Radio telecommunications.
Yeah. I'm straight up yelling from the top of my lungs on a fucking radio dish.
Explaining people how the stock works and stuff.
Yeah.
I'ma keep it a stack.
I'm gonna keep it a stack.
You should not explain. You should leave people in hanging. You should read on your own and keep the knowledge to yourself. That's why I'm gonna go quiet right now.
Oh. So you're not gonna turn the audio up in OBS?
What?
You kinda. What?
Oh, you're saying you sound quiet.
Yeah, that's what I'm saying. I pulled up the live stream.
By the way, people are commenting that they don't want to hear you, so
Oh no!
let's keep it the way it is.
Let's keep it a stack.
I'm gonna keep it a stack. I'm gonna keep it a stack. No one wants to hear you.
Damn, bro. I was just learning about it though.
People like guessing. Keep them guessing what you're saying. So stack. Let's see, I'm coming from Funk 1, right? Alright.
I like that you already know, like, people like guessing. like like it's common knowledge. People like guessing. Yo, pull that OBS shit up and you talk and I talk and let's compare the levels. Yo, say something. Why you keep it quiet?
Free Ice Spice.
Yo, Free Ice Spice, you locked up
Why is she locked up though?
because she. I don't know.
Well, I'm gonna be honest. This wasn't planned.
What do you do?
Anyway, I'm coming from Funk 1, right?
You looking funky up in that bitch.
So every function basically does push BP.
That's kind of great. Ayo, shut up! Alright, sorry about that.
Crowd control. That was the crowd control police right there.
Bro, you remember that one computer file video that basically explained what you're doing?
So what are you implying with that?
I don't know. I'm just saying if you know it, bro. That there's no like alternative or what do you say?
But it's fun to rediscover it on your own, no?
What are you gonna rediscover the wheel? You're gonna reinvent the wheel? What are you thinking?
Invitation? You know, invitation means like when you invite someone. Okay. Invitation contest.
Bro, read it.
Agree.
Read it.
Take the chance. Take the floor. Wait. Take the chance and
Wait,
take
wait,
the
wait.
floor.
Either
What?
you read it correctly, or I'm lowering your volume, turning
Oh
it back where it
no,
started.
bro. This is some authoritarian shit. Literally 1984, bro. You can't silence me like that.
When it's not like we're afraid of you. What you gonna say? You're just embarrassing us.
Bro, you shouldn't silence me other way, bro. Sorry.
I'm telling you, just read it. One more time, I'm gonna hear it.
So basically, invitation contest. Bro, listen. I'm running up 4 hours of sleep. Shut the fuck up. So basically, invitation contest. Take a chance.
This
What?
this this person was trying to explain to me what stack, what what this and what that is.
Listen, I'm not book smart, but I'm clever. I don't need to know inventation contest, okay? Or whatever that means.
I don't know who's
Okay,
in
you
a.
know that
I'm trying to figure out who's in a worse position right now. Me, who is like has to listen to you, or you saying those kind of like, I don't know.
bro, do you know that saying? Do you know that saying? I'm not book smart, I'm money smart. That's me. It's
Sure.
not like it clearly says innovation contest. Yeah. No, you see on my screen it's a little different. The font is a little hard to read, bro.
I get it. I get it. This Hardy took your this broad took your
Ah,
attention.
bro, that broad, bro. My eyes were split two ways reading that fucking one looking at the hottie, one looking at the invitation contest. Bro, well, what are you looking at?
I'm just like, I'm gonna present
You're
my.
in shock. You're in shock that I dropped the invitation contest.
I'm gonna. I was going to say that I'm going to present a wheel to this contest,
Uh.
but it's
Well,
all gone. The joke is gone. Everything is gone.
your life,
My
your
career.
future, career.
Okay. If I'm not able to, then I'm not able to.
You're not able to invitation the contest. That's it.
Let's keep it a stack.
Look, yeah.
We are here. This is a two-person. Um,
2-person squad.
no, two-person squad. Two-person squad is like open secret.
Bro, that's that's crazy. The open secret. That's like a good book title.
Two-person squad is like a two-person trio. Like, you know what I mean?
The 2-person fucking squad. Yeah, that's good.
Two-person squad. Yeah. By the way, did you see this?
Well, I show speed. Oh yes, yeah, I see that.
It's coming next month.
Next month, isn't it like 15 or where is it? Bro, I ain't got no time for that, bro. Next month is school, bro.
Oh, Yo, it sounds like I'm passing trees while moving really fast with my car.
Me? Am I involved in that? Is it my fault?
Yeah, I don't know, some kind of sound.
Or is it like,
Something generating them, not sound.
then there's no other answer than you're actually in a fucking car going through trees. It's not me. That's crazy. Oh my god, that's crazy. Oh my god. That's great. Oh my god. That's great. Yo, that's crazy.
Yeah, did you try to write with a tablet?
I mean, it works. Yeah.
The drivers was not a problem. Did you have to install anything or not?
No. Worked out of the box. Well, I mean, I installed Krita. Maybe I installed something with it.
I don't think so. So it worked right away.
What'd you say?
I don't think Rita installed anything. It's probably worked straight up.
Yeah, probably.
Why do I have hard time understanding this? Like push BP, all the base pointers stored on the stack. This happens in the beginning of the function. Move BPSP. Base pointer is now at the top of the old stack. Yeah, top of the old stack and bottom of the new stack. This also makes sense. And sub SP4. Reserve 4 bytes on the stack.
That's crazy.
SP.
What are you doing right now? Are you writing shit on paper?
I'm chilling.
Alright. So, okay, so deep noise removal, actuation limit. What the fuck does that mean? Yo. Oh shit. Oh. Wait, I don't get it. Oh, okay, that was the problem. Okay, now fixed.
Right, I get it.
He gets.
Next time we'll get into this.
Oh, what's that? That's kind of crazy. You're kind of crazy for. Oh wait, that's the fucking philosopher, bro.
Alright. I'ma hop
Yes.
out.
Alright.
And by
Wait, what?
I'ma
What's your
hop
phone?
out, I mean
Oh my god, it's almost 1 a.m. Are you fucking kidding me?
go
And then this guy's gonna
and
call me at 6.
sleep. That's a skill issue, I would say.
Yeah, sure.
Like how would you look into the eyes of Jocko Willix, David Goggins,
The great
Joe Biden?
Biden. He kind of sleeping though. I'm not gonna lie.
Like, there's two ways. Either you're gonna say that he's always sleeping or he's never sleeping, which depends which way you go.
If you're a Democrat, if you're a lib, that's what you would say.
Because on the look of it, there's no transitional state that you would say, okay, he went from one state to another.
One or the other.
Anyway, stop yapping.
Auto stop? Oh. You will not be reconnected. Your stream will no longer be live. Goodbye! Bye!